This question has really good information for better understanding slope-intercept form. So we're talking about from 1970 to 1990, the average person or per person annual consumption declined at a constant rate, and it went from 101 to 41 quarts per year. Now, whenever you see information like this, particularly you could think of it as like 4 pieces of information, we want to turn those into ordered pairs. And the reason we know it's going to be linear is because of this constant rate phrase there. Whether it's declining, which means it's going to have a negative slope, or increasing, which would be a positive slope, still it's going to be slope-intercept form. So how do you know whether the 1970 and 1990 go in the x spot or in the y spot? Well, when you're looking at any graph, you have x as the independent axis and y as the dependent axis. Time is always independent of everything else. I always say this, it doesn't matter how fast you run, how high you jump, how much you study, time is not going to change. It's going to keep going at the same rate. So the year or day or month or any of those time concepts are going to be the x coordinates. And then we want to do this in the same respective order. So 1970 was the first year, so that corresponds with the 101 quarts, and then 1990 goes with the 41 quarts. All right, so that's one scenario. Then they mention that we also have, during that same period, so in other words, again, from 1970 to 1990, the low-fat milk increased, so positive slope, at a constant rate, linear concept here, from 25 quarts to 60 quarts. All right, so that's really key, and you would have put this on your scrap piece of paper, so assume that you have that in front of you. And what we're going to do now in Desmos is pretty spectacular. Keep in mind the goal here, we're trying to find the average consumption, which was our y-coordinate, when they are the same. In other words, when they're equal. So let's go in here, and we're going to create a table. And you always want to do that when you're trying to find either the slope or the equation of a line. So let's put 1970 and 101, and then 1990 and 41. We click on this add regression. By default, it does linear, but if it were something else, or if you're trying to get some other kind of regression, you do the drop down. So here's the equation, and I'm going to export it right here. And now let's go here and do the exact same thing where we make a table for the second scenario where you have 1970 and 25 and you have 1990 and 60. And then same idea, linear regression. So we click here and then we take that and export it. And so now it's graphing lines 2 and 4. And so what we're going to do is look for the intersection of those two lines. And now once I found where it is, I really want to zoom in there. So I'm going to put it at the center, zoom in, because notice it's identifying a few different points, and I want to make sure I find that intersection right there. Let's export it so we can look at it. So it's saying in 1986, they ended up having the same consumption, but the consumption of quarts was 53 quarts, making the correct answer A.